Welcome to Electricity and Magnetism, Part 3, Electrical Potential Energy. And the electrical potential energy we're going to look at right now is static electrical potential energy. That means the energy between two charged bodies. We'll look at the energy of moving charges later. When we say two charged bodies have a certain amount of energy between them, we say that we know that a certain amount of energy is needed either to bring them together for like charges or pull them apart for unlike charges. And the 0 point for all of this is when the bodies are an infinite distance away. So if I have a proton sitting on my desk and I bring another proton from the other side of the universe to it, I must do work. And the amount of work I do increases the energy of those two particles. And the energy of those two particles is given by K Q1 Q2 over R. And we use the symbol U to represent that amount of energy. Now the change in potential energy when we bring two charged particles closer together or farther apart, for example, if we have two charged bodies and we move them a couple microns apart or a couple meters apart, is calculated by that, which should be no surprise. The change in potential is proportional to 1 over the distance between the bodies. Do a quick example here. What is the potential difference between a minus 2.5 microcoulomb charge and a 3.2 microcoulomb charge that are 5.0 microns apart. I'm going to use this equation right up here. I'm going to calculate the energy between the amount of energy between the two bodies. Coulomb's constant is the same, it hasn't changed. First charge minus 2.5, 10 to the minus 6 coulombs. Second charge 3.2, 10 to the minus 6 coulombs. And the distance is 50 times 10 to the minus 6 meters. Doing a little bit of the arithmetic gives us a numerator. That's a 1. Doing a little bit more arithmetic. And we know that a Newton meter is nothing more than a joule. So minus 1.4 times 10 to the 4th joules of energy exists between these two bodies. Example number 2. How much work must be done? To move a plus 1.5 microcoulomb charge, 3.5 microns, closer to a plus 2.0 microcoulomb charge. Makes sense? Both charges are positive, they repel each other, therefore we have to do work to push them together. Again, doing a little bit of arithmetic. Again, notice that the coulombs and the coulombs reduce. So the change in potential energy is 7.7 times 10 to the third Newton meters. And a Newton meter is nothing more than a joule. So we had to invest this much energy or do this much work to bring those two like charged particles together. Hope this helped. Please feel free to leave a comment. Let me know if this helped, didn't help, something you want to see more of, something you want to see less of, more examples, and so forth. Thanks.